uma grande honra, um prazer enorme, né, ter aqui com a gente o professor Wolfram Meier-Augenstein, né? Ele é professor em Ciências Forenses e Ciências Analíticas dos Isótopos estáveis na Universidade de Robert Gordon, em Aberdeen, no Reino Unido. Ele é membro da Royal Society of Chemistry, e em 2004 ele foi admitido no registro de peritos forenses do Centro Nacional de Excelência Policial do Reino Unido, o NCPE, e desde 2011 ele está registrado como consultor pericial forense junto da Agência Nacional do Crime do Reino Unido, o NCA. Entre 2010 e 2014, ele foi diretor do FIRMS, que muitos de vocês já devem conhecer, que é o Forensic Isotope Ratio Mass Spectrometry Network. Ele é membro consultivo da Rapid Communication Mass Spectrometry e membro do conselho editorial da Isotopes Environmental and Health Studies. São duas revistas, né, aí do mundo isotópicos. Ele auxiliou já forças policiais e outras agências forenses do Reino Unido e no exterior em mais de 30 investigações relacionadas principalmente com drogas e homicídios, com fornecimento de informações forenses baseada nos isótopos estáveis. Ele possui mais de 150 publicações e ele, né, tem hoje o primeiro, né, na verdade, ele foi, né, o autor do primeiro livro dedicado à aplicação forense de técnicas analíticas isotópicas, com o título Stable Isotopes Forenses, e que, né, a gente já tem hoje a segunda edição atualizada em 2018. Então, né, com vocês, né, vou deixá-los agora nessa próxima hora, né, podendo aí aproveitar ao máximo, né, o conhecimento do Dr. Wolfram Meier-Augenstein. So that's it.
That's it, right. Okay. Yeah, then thank you very much, Gabriela, for the introduction, and also thank you very much for inviting me to give a talk at your workshop. And yeah, thank you to all the invisible audience for having me. Good afternoon. Although it is actually quite dark and no longer afternoon in Scotland, but let's get started. Given the title of the talk, I could just not help myself not use this slide as to begin with, and because CSI clearly stands for Crime and Stable Isotopes. And given that slide, I then figured I use this picture not only to introduce myself to basically so you know what I look like below the chin line, but also to make the point that when it comes to actual casework, in this case, walking into a crime scene, or rather into a body deposition site, there is no such thing as Armani suits and deck shoes and funny sunglasses. This is what it looks in real life. At least this is what it looks like in reality in the United Kingdom. So the actual title, our multi-isotope of the talk is our multi-isotope signatures, forensic intelligence tool, or evidence, or maybe both. And I'll try to answer the question by giving you a few examples. So when it comes to being contacted by the police, I always get the impression that most police officers, most investigating officers, they sort of whatever, they sit roughly here, because then they haven't quite, and you can't really blame them, have a feel for what we do. And I sometimes wonder whether we just sort of rank in somewhere in the same area as people who use a crystal ball or a dowsing rod. So yet when there are problems, they do come and they do ask, and we try our best to help. So given the audience is quite wide, and I'm not quite sure how well into stable isotopes everybody is, I thought I'd give you sort of a very, very short crash course using carbon isotopes as a way, in the first instance, to illustrate what's happening here. So stable isotopes of the same element are, as the name implies, stable, so they're not radioactive. And the only really difference is the weight. And the next difference is that typically the heavier isotope is far less abundant than the main abundant lighter isotope. In the case of carbon-13, the numbers are 1.108 atom% for the carbon-13. But this number is a global average. This is only true if you would look at all the carbon in the world. The moment you go into, and let's call it microcosms, i.e. the moment you look at plants or at animals, anything that lives, anything that basically, or any situation, any environment in which chemical processes or physical-chemical processes happen, then things start to move away from this typical abundance, and they typically happen here way beyond the decimal point. And because these changes are quite small, that is not to say they cannot be measured. They can, very accurately and very precisely. But because the changes are so small, they are best expressed against a reference point. And because they are expressed against a reference point, and because of the way that the reference point was originally chosen, we end up with rather small numbers. First of all, you will notice in this example, they are negative. That's nothing to worry about. That doesn't mean there is something wrong. It just means the carbon-13 abundance in the case when this value in the delta notation is negative. That means there is less carbon-13 in the compound that we investigate compared to the international scale reference point. Conversely, if the number would be positive, that would mean there would be more carbon-13 than the scale reference point. But you can already see if numbers are something like minus 0.02 or minus 0.03, eventually you lose the will to live. I mean, so we need something more convenient by way of expressing these numbers. And the moment you express something against a reference point or a reference population, you all know what typically happens. You use percentages, and percentage is nothing but a number times 10 to the minus 2. And so we used, in essence, the same trick, only we used 10 to the power of minus 3, which then means a number like minus 0.02 becomes minus 20 per mil. So that's all there is to it. It is just a convenient way to express small changes. So in subsequent slides, when you see numbers like this, you have a feel for what they actually mean or where they come from. So this is not a unit of measurement. This is just a mathematical parlor trick, in essence, to conveniently express small numbers in a way that are easy to pronounce. And by looking at this, you can probably already tell, or you will not be surprised by the next slide. If we now look at, for instance, the microcosm vegetation, and we look at that at a global scale, these minute changes are actually quite startling. And there are sort of certain things one can take away from this carbon-13 map of our carbon-13 in vegetation, in plant material. The moment you are in the hot, arid climate region, you have plants that present that have learned and have adopted, have evolved to deal with such a harsh climate, and their carbon-13 signature is much closer to that of atmospheric CO2, which is in essence the precursor pool for everything that's carbon in the plant world. While in moderate climates, you can see that the carbon-13 signature is much lower, i.e. there is much less carbon present as compared to the scale reference point, or as compared to the precursor CO2 in atmosphere. Similarly, and so the reasons for these differences are the biochemical processes, in particular the CO2 fixation pathway, which is different between hot and arid adaptive plants, the so-called C4 plants that employ Hatch-Slack, the Hatch-Slack cycle to fixate CO2, as compared to the moderate climate, lots of rain, not the plants, the C3 plants that use the Calvin-Benzene cycle. There is another driver that leads to isotopic abundances differ depending on location, and these are physical-chemical processes. When water evaporates from the oceans to form a rain cloud, for energetic reasons, because of differences in vapor pressure, boiling point, melting point, you name it, the isotopically light water evaporates preferentially. However, the moment that rain cloud now meets a landmass and suffers a temperature change, the converse is true, again, for energetic reasons. Now, whatever is in the cloud by way of slightly heavier isotope water, that will precipitate first. And this is why in close to the equator, in close to coastal region, we have compared to the scale reference point, we have water that is more has more hydrogen 2 and more oxygen 18 in its molecules than when we move to higher latitudes, to higher altitudes, into much colder climes, and where basically the final precipitation process, because it's sort of a continued cloud is formed, first rainfall, but not all the cloud rains out. There is some remaining that moves on, and this process repeats itself several times. And over time, basically, you have sort of a step down fractionation process that always what rains out is always slightly heavier, isotopically speaking, than what remains in the cloud. These two things together basically can be put into this sentence. While some isotopes yield information on the source of something, i.e. made by what or by who or by which process even, other isotopes provide information on origin, namely made where. So I sometimes know people sort of use source and origin interchangeably, but one really shouldn't. Source is origin and source have defined meanings, and I will use source and origin exactly in that way in the following slides. So a practical application, everybody who ever played in school, preferably in mathematics lessons or other unpopular subjects, played basically battleships, will be able to read this without any further explanation. We have basically on X and Y hydrogen isotopic composition on Y, and a carbon-13 isotopic composition on the X-axis, and you can see that sugar derived from beet sugar, from sugar beet, is isotopically distinctly different from sugar that has been made by the plant sugarcane. Sugarcane is one of those hot, arid, climate-adapted plants, whereas sugar beet is a plant that happily lives in moderate, well rained upon climates. And even so, these are all sugars extracted from sugar beet. There are still minute differences in the carbon-13 signature, which sort of relate to things like water stress to some degree, but also to biochemical activity. And there are, of course, location specific differences in the hydrogen isotopic composition, because for a plant, the only precursor pools available for carbon is atmospheric carbon dioxide, and the only precursor pool available for hydrogen is hydrogen in water, i.e. in precipitation. And likewise, in essence here, you can see the carbon signature for cane sugar is actually much tighter, yet the hydrogen isotope signature still is quite different depending on where the sugar cane was grown. So this is basically ultimately the reason why what we do actually works. There are differences in chemical processes that result in differences between precursor and product, where carbon, for instance, carbon or nitrogen isotopic composition are concerned, and there are differences in hydrogen and oxygen that, of course, are also to a degree at the result of biochemical or synthetic chemical processes, but have also to do with where the water was sourced. So if we now transport all this into forensic science, and bearing in mind the title of the presentation, you can already see basically where this will go, because forensic science, and I showed this slide to my students, and it's actually not my slide. It was originally prepared by a colleague who used to be the head of physical evidence for the organization that was basically the pre-runner to what's now the National Crimes Agency, David Barkley. And I thought that was such a wonderful slide, so I asked him if I could use it, and he was quite happy to. So forensic science is nothing abstract. Forensic science is clearly defined as the interpretation, or even and of course investigation application of scientific tests and the observation in the context of individual legal case circumstance. So any science applied in the context of individual legal case circumstance becomes a forensic science. The next thing is that forensic science is about the interpretation of ultimately of the results in context, not necessarily about the results per se. And following on from that, forensic science is absolutely context dependent. And that is important. And I've always tried to follow this. When I did work for law enforcement, I basically started out knowing as little as possible about a case. So there was no confirmation bias, there was no sort of preconceived idea what the results would be. But the moment it came to interpretation, after I formed an initial assessment, I then asked for context, because more often than not, the results were not just leading to one single answer, but they were consistent with a couple of even more scenarios, but the context then allowed me to list these scenarios sort of by order of probability. So the important thing about all this is that the primary function is really to provide intelligence, to support an investigation, even help focus in investigation. And when, while it's focusing on investigation, it also helps law enforcement to bring their resources to bear in the most efficient way. And this is something I've always found, and I always was sort of received as a feedback. This is immensely useful to police and cannot be underestimated, because when I started out doing casework, I always thought they wanted, in essence, sort of a take-home solution. X marks the spot. Yes, of course, in an ideal world, but what we can, if we can provide information that helps them advance their investigation, they're already immensely happy. So on balance, I think what we do with stable isotopes in a forensic context is to the majority of our work provide useful, helpful intelligence. And yes, on the rare occasions when that information, when those results, when their interpretation are presented as or given as evidence in the court of law, then of course the intelligence turns into evidence. But evidence is closed. Mind you, there are in the meantime ways to reassess things and say, fine, in the light of developing science, we have to re-examine or even reassess. But as a sort of really black and white statement, intelligence is open, evidence is closed. So, with one exception on that slide, namely disaster victim identification, and that might change, even though it's not strictly disaster, it will probably move into the area of mass graves after conflict. In all these other areas that you see here, drug, terrorism, people trafficking, homicide, forgery, and anti-doping, stable isotope signatures and multi-isotope signatures have already been used, and there are numerous publications that evidence that. One of the first things we did was getting involved in drug analysis, and you can clearly see if samples look like that, how do you tell? Is there a linkage, or are they all completely unrelated? And we thought Surely with stable isotope analysis, we should be able to provide some pointers. And one of the first things we did, we asked a police force, a particular police force in the UK, where we knew there was quite a lot going on in the amphetamine world, if they had samples for, where they already knew what the story was, and if they were prepared, if the cases were closed, to give us subsamples and let us analyze them and see if the interpretation we come up with matches what they have said, either 100% or at least to a lesser degree. And this was basically what happened. So we had 18 samples from 6 sources, and we analyzed them in the first instance because that was where we thought would be a good deal of information to be had. We analyzed them for carbon and nitrogen isotopes, and with the exception of these 2 samples, all other interpretations with regards to nothing to do with this or being or those 2 are being, or those 4 or 5 are actually related. There is a link. All our assessments were absolutely correct. And you can already see by the inserts here that a standard chemical analysis would not necessarily have provided this information, because in these 2 samples alone, the amphetamine content differed by 2.2%. And here the range in these, the range was even greater. The reason why these 2 were not identified by us as part of this group or as part of the seizure was because by no stretch of the imagination could we have said, yes, they are linked. No, they look basically outside and they're further away from this group than this isolated thing is from this group. And we wondered why this would be. And given the differences on the carbon scale for that one and the difference on the nitrogen scale on that one, while basically on the other, as you see, there's no difference in nitrogen, but there's a difference in carbon. And here there's no significant difference in carbon, but there is one in nitrogen. So we thought, right, this might have to do with either this particular dealer got his material from a different source and just packed it with everything else, or his supplier, they've changed the recipe, or a particular batch, the reaction conditions were not as well controlled as they usually are, or in this case, this might be from a batch where the precursor came from a different source. So we started the research. We started several research projects and luckily got funding from one of the UK research councils and looked at the systematics. So under controlled conditions, using here, for instance, pseudoephedrine from a chemical supply company, and always using basically material from that one pot. But cooking different recipes, and in this instance, the 2 major clandestine lab favored recipes to make methamphetamine are the Moscow root and the hypo root. And lo and behold, the difference this makes depending on which synthetic root is being used. You see, the Moscow root has a pronounced effect on the carbon signature, and it also has a very pronounced effect on the hydrogen signature, whereas the hypo root barely makes a difference for the carbon. Yes, there is one, but I mean, look at it. Look at the degree of difference. Here it is behind the decimal point. That's roughly twice the error of measurement. And here we're looking at minus 2.17, i.e., well in front of the decimal point. There is a shift in hydrogen, not as large as this one, but interestingly enough, in the opposite direction. And this despite the fact that if you look actually at the recipes, they both use iodine, and the only difference is the Moscow root uses red phosphorus and the hypo root uses hypophosphoric acid. So there is something happening in these reactions that has a pronounced influence on what is the rate limiting step, how fast does this proceed. And the other thing, of course, and this is one of the other reasons why I choose this example, I'm always surprised that people actually use this reaction. There are other reactions that make my head shake, but this one in particular, because both methods produce toxic flammable side products like phosphine and diphosphine. I mean, luckily they smell very awful, and I don't think anybody has died as yet, however, from the toxicity. However, these gases are also flammable. They can ignite spontaneously, and they can form explosive gas mixtures with air. And this is sort of one of the examples where intelligence that comes from forensic isotopes or even from the traditional chemical analytical methods might often come after the fact, because it's not the police who finds the clandestine lab first. It's typically, when things go wrong, it's the first responders like the fire brigade and the paramedics. And I mean, this used to be or somewhere in here there used to be a clandestine lab. And if you look at the shape of the swimming pool, and you can see by clearly this house was probably built by the same builder as this. So. And it shows that making this stuff is not only dangerous to the people who make it, it's also dangerous and hazardous to people who live in the neighborhood. Another case, staying with drugs, we did for the Scottish Crime Drug Enforcement Agency, as then was, where we had plenty of material. Occasionally, we had 5 barrels in the lab with an individual weight of 20 to 25 kilogram content. So sample availability was not a problem, and we thought, oh, that's a good opportunity to actually demonstrate and actually look for ourselves in the first instance to our own satisfaction if we can actually meet one of the vital conditions for any kind of analytical work. Can what we do be externally validated? Can it be reproduced by an independent lab? And luckily, in Australia, the Forensic Drug Laboratory in Pimble were happy to oblige, and we didn't even tell them to use our protocol. We thought the real-life experiment here or study is they do it using their SOPs, their instruments, and we just see what happens. And fortunately, as you can see, most of the times the data were literally on top of each other, and on the few occasions when they were not, they were still not significantly different. They were within the error of measurement. And that, of course, then made us quite confident that if that's the case, then any interpretation based on the results should not differ no matter which lab had carried out the work. So if you now analyze the data using things like principal component analysis or hierarchical cluster analysis, we should come to the same result there and should draw the same inference, should draw the same conclusions. And this is basically now the PCA plot of the data you saw on the previous slide. And these colored rings signify the following. These 2 data points are the results of the same standard, but taken in 2 subsamples. So from a forensic lab, we asked them for a subsample of their lab standard, and we asked them to take 2 subsamples from the same pot, because in essence, as a benchmark, how identical is identical when we know it's identical, but we actually analyze them as separate samples. And these were seizures as part of the operation Kylon and these were another set of seizures. And you can see those 2 seizures are not related, but the different seizures within that particular case that came under that same umbrella operation, they are related, and quite clearly those 5 are related as well. And then I thought, this was going to court, and I thought, and I had to give evidence, and I thought, right, even the PCA plot might not necessarily convince a jury, because there's typically the expectation things are only identical if there is 100% similarity. Of course, you and I know that's not the case. I mean, this is like expecting that in a box of 100 screws and 100 nuts, they're all identical. And of course they aren't, which is somewhere written on the label that are actually the manufacturing specifications that tell you what the tolerances are. But trying to get a jury to sort of make the leap from manufacturing tolerance to measurement uncertainty. So I thought, right, let's do a picture. Let's do a topographical representation, because you know the saying, a picture says more than 100 words. So we plotted those data in this three-dimensional plot, and this here are the two subsamples of the same pot of lab standard from the forensic lab that provided us with a sample. These are basically the case 1 within Operation Kylon, and this is basically case 2 within Operation Kylon. And interestingly enough, the similarity of the two samples that came from the same pot was actually less. It was something like 92 or 93%, whereas here we had 95 and 94. And I thought, okay, so if things we know came from the same pot, have a similarity of 92 or 93, then surely nobody in a jury will say, oh, we don't accept the similarity of 95 or 94 for the actual case samples. More importantly, I actually thought was the fact that this plot now clearly shows that there is no linkage between these samples to those samples, and there's clearly neither of these have anything to do with this lab standard, because you can see there is a deep valley or chasm, if you like, between those. As it so happens, that never went to, the case went to court, but I never did, because the defense, of course, has the right to have access to all the evidence the prosecution is going to present. And literally the day before, we had already the train tickets booked and everything. The day before we were supposed to appear in court, we got a phone call, you don't have to come. The defendant changed their plea from not guilty to guilty. So even though it was not presented in evidence, the forensic intelligence produced a result, namely secured a conviction. And just to sort of wrap up the drug stuff and going back to basically what happens naturally, this is work by the people at the Drug Enforcement Administration in the US, in particular Jennifer Mallette and John Casale, who very kindly let me have their isoscapes for my book, and also for my presentations and lectures at university. And this is just Colombia. I've seen the work also they've done on Peru and Bolivia. And if you would have said, okay, I'm prepared to believe there are differences between Colombia and Peru, but I would never expect there will be any exploitable differences in the isotopic composition of cocaine from coca leaves harvested in Colombia. And yet there you are. There are immense differences. And even in those areas where there is not much difference between whatever the northern area and the more southern point area, there are still differences in nitrogen, and there are also differences in hydrogen. So that, which means basically, while on the basis of one isotope, you might not be able to come to a conclusive interpretation. The moment you add, and this is why I'm stressing this multi-isotope or multivariate point, the moment you add one isotope to the next and you create these lovely maps, if you would now overlay all three, I tell you, you would not find 2 points, two disparate points on either end of the country where you would have all three values coincide. And this is where the real power of this technique lies. And this is where I see this technique going, namely extend what we do. Yes, exploit all the stable isotopes we have. Mind you, sulfur might not always be an option, or rarely is actually. But already exploiting these is already quite powerful, because there are, in the lingo of statisticians or chemometrics, there are independent variables. The carbon has nothing to do with hydrogen, and neither hydrogen has nothing to do with nitrogen. There is, of course, some correlation between hydrogen and oxygen, but it's not as strong as you would have thought, because oxygen can also be recruited from atmosphere. There are biochemical processes that can make use of oxygen as O2 and not necessarily and don't need oxygen bound in water. But the moment you then start to add other isotopes, trace element isotopes, strontium, lead, yttrium, neodymium, you can basically go for things that are really tied into the local geology. You can even add trace element concentrations, and then basically layer these like in a multi-layer cake using software like ArcGIS. I would imagine it will not take long, and we might actually manage to find unique signatures, at least for things like drugs, or especially drugs that actually have been extracted from plants such as cocaine or opium, and even if it's been derivatized to make the heroin. The majority of the original signature still remains. So from an intelligence point of view, stable isotope or isotope analysis in general has a lot to offer. It provides decision-enabling intelligence, and it helps linking things. It helps you link the crime scene to the perpetrator, or vice versa, the drug to the network, or the clandestine drug lab. If it hasn't gone up in smoke because the people basically were careless and the thing exploded. But if you can find a lab, and you have access to the precursor chemicals, you should be able to establish a link between the precursors and the drug. Similarly, and even more importantly, explosive and terrorist cells, because typically terrorists operate in cells where the left hand doesn't know what the right hand is doing. So one procures the precursor, and the other one makes the explosive, and the third one goes off and blows themselves up. But if you have access to these, or you can even say, okay, we have this explosive, the typical reaction to make that goes like this, we have a good expectation that the isotopic signature of the precursor, let's say acetone, should be in the ballpark of that. And that is already quite powerful. And last but not least, and that leads me then to coming more, hopefully, to a close soon, you will be pleased to hear, linking an unidentified person, let's say a victim of serious crime, to their personal identity, because it's unbelievable what some people get up to in order to cover up their crime and basically deny a dead person their identity and exercise your fantasy at your discretion by removing various body parts. And this is why I really love what I'm doing, because it gives me a certain satisfaction. Not only because when most of the work I've done was actually not drug work. Yes, there was quite a bit of it. Was dealing with human remains, and for me, there was always the aspect that, other than helping the police with their investigation, is to give somebody the identity back. And not only so there is that they're not being buried in an unmarked grave, but for the nearest and dearest to actually know what happened, to provide closure, because nothing is worse than your uncle, your son, your daughter, your auntie, your mother having gone missing and never known what happened. Have they just left us, or what happened to them? Where are they? That is a huge mental burden, a psychological burden, and knowing what happened is much better than not knowing. So there is a humanitarian aspect when it comes to dealing with human remains, and the most basic human right is the right to your personal identity. And this works because the human body is quite an interesting machine. Those that of you who are a similar age as I am will I would imagine remember these reel-to-reel tape recorders. Yeah, these huge things that could be operated on several recording speeds. And this is exactly what happens with the human body. First of all, what your body is is made from what you eat and what you drink. And it's not just what you eat and what you drink, but also where you consume your eat and drink. And then your body starts to behave like a reel-to-reel recorder. And different parts of the body have different memories or different recording times. And so the fastest ones are typically hair, and to a degree nail. Once they're formed and out of the body, i.e. grown out of the skin, they no longer remodel. So there is no back exchange with what's happening in the body, and they grow relatively fast. So depending on the length of hair, the length of nail, you get actually very nice chronological, even i.e. in tiny intervals of a month or even a fortnight intervals, information on what these people sort of life circumstance, i.e. what roughly what was their diet like, have they moved or haven't they moved, and then there are tissues that either do not turn over at all, do not remodel once they have been formed, such as the enamel of your permanent teeth, where, for instance, a late erupting molar, like the wisdom tooth or the preceding M2. Here, the crown mineralization happens during age 7 to 15 years. So you have a time averaged picture of a person's youth, and femur. Load-bearing bone, depending whether you're a woman, then it's 20 years, or a man, then it's typically 25 years. This entire thing here remodels. So if somebody tells you you are not the person you once were, they're actually quite right, because you are not. Your entire skeleton remodels continuously. So it's not in-out exchange, obviously. It's a continuous process, which of course means, given the timelines, that you have a huge time effort signal here. But in combination with information from other tissues, this is still powerful information, because it gives you a picture of a person's past. And if you if you put all this together, while it looks really sometimes very fascinating, one thing, and I always tell this to the investigating officers, one thing they should not expect: we will not provide X marks the spot. Not possible. Not even house number or street name or anything like that. We do not find the needle in the haystack when it comes to human remains. And but what we do, we reduce the size of the haystack to a manageable size. So remember, we come back to intelligence providing information that will enable the police to focus their investigation and to bring their resources to bear. And this is already based on one isotope. Look at everything that's gray, whether it's dark gray or light gray, is excluded. Only the colored portions are potential regions of interest. Yeah, and this wonderful map was created by Ewan Hoogerwerf, who's now at the University of Canberra. And the moment we add another isotope, all of a sudden everything disappears, with the exception of these regions. So if your unidentified person is, let's say, a Caucasian male, yeah, in this day and age, freedom of movement, air travel relatively inexpensive, relatively speaking, and then go into a city that is very popular as a tourist tourist location. Can't at the moment grasp the word I'm actually looking for. Destination, that's it. Sorry for that. So a popular tourist destination, and something happens. I mean, just remember Phuket. Yeah, I mean, I think that example, the Christmas tsunami, is still vivid in the memory, but also the bombings in London. So everywhere where white male IC1 could have come from virtually any place. So how do you narrow your investigation to something manageable? And that's basically here. And in this case, basically, Operation Monten, we were dealing with a headless body. So we were really using whatever we could, because facial reconstruction wasn't possible. a tooth analysis was impossible, and still we managed to reduce the search area where this person might have been reported locally as a missing person could have come from. And the latest trick that the Urian is now using, rather than produce isoscapes, he basically analyzes the data using Bayesian methods, and he produces likelihood ratios maps. And I think that's absolutely fantastic. This is a case I didn't work on, that was worked on by Urian alone. And he looked basically at strontium and oxygen. This is where the victim, where the woman was found near Bergen in Norway. And you can see likelihood ratio that she came from Norway, 0. Likewise, any other Scandinavian country, virtually the best part of Central Europe is definitely out. Look at the color, and the likelihood ratio points to these few locations. So this is the power of this technique. This is the intelligence it provides, and this basically now means the police can actually, the Norwegian police can contact police forces in these areas and see if they find something in their database that might actually tie in with that unfortunate woman. And lastly, a case that I worked on, which differs from the previous cases, because here the identity of the victim was known. What was not known, and the police was exceedingly interested to find out, is how did he come up? How did he turn up in the country? Because there was at no port of entry to the UK was there any record that this person had actually passed passport control. So this is basically, whatever you can tell us, please tell us. And I thought, right, then give me, and I gave them my shopping list. And unfortunately, the only thing I got, or fortunately in retrospect, as it turned out, was this lock of hair, which was long enough to produce this. So we analyzed it for hydrogen, and we noticed that apart from the location where the body was found and was supposed to have lived for the last 2.5 months, there were distinct 2 further locations where the person had lived before for a longer period of time. You can even see there is a direct transition from location A to location B. Here it got tricky because clearly there was movement, but the person never stayed at a particular location long enough for a plateau to develop. What was also interesting was this, when we looked at the nitrogen signature. And I thought, that's odd. I mean, you can see these shark fin, the seesaw movement here. And if you come down to here, you can see if the hair would have been even longer, I bet you anything we would have seen the ascending part here again. And I thought, right, either this person is the most unhealthy or most unluckiest person in the world, and at regular intervals that by strange coincidence correlate with his movement, he caught a serious infection that caused his body to basically attack its own tissue to make enough protein. Or, on the other hand, he might have actually been asked to go on a crash diet so he could be moved, which in turn would mean the way he was moved was space constrained. So in my report, I mentioned this, and I said, if you reckon that he was brought in the back of a lorry, forget about it. You don't need to lose weight to fit in the back of a lorry. Where there are already 15 others being smuggled across, and translating these locations into probable locations, we sort of figured that as the most probable scenario, that he was basically in the Ukraine for at least 3 months before he was moved to Germany, where he lived for 6 to 7 months, and then he was moved to the UK. These 2 points, I have to admit, were not our work, because, as I explained, before he came to live here in the South Wales area, those results from the analysis would just not be tied to a location, because there was no plateau. And as it turned out, as we've then learned later, yes, he only stayed here for a couple of days and then was moved here again for a couple of days. And presumably there were some other staging posts in between. This is ultimately what our conclusions were. And as always, we always list everything that is consistent with the data. But we, in our report, we of course we order things by probability. What is the most likely scenario? The most likely scenario for this point was South Wales. Here we couldn't really say Germany or Czech Republic. That was sort of 50-50, and likewise Ukraine or Romania, but we could exclude virtually everything else. And then, of course, this observation of nutritional stress that was correlating with the changing geographical location. And this is basically what we eventually learned from the police, that what they found out, but then focusing the investigation, also basically double checking with Interpol and with the German police. And this is in essence what happened. And you can see that with the exception of this, which we couldn't tell that the person came originally from Vietnam, because we had no tissue that would have gone back that far in time, everything matched. So that was actually quite satisfying. It was even more satisfying when acting on our intelligence at the ports coming into the UK, either by ferry or by the train, the Eurotunnel train, this was found. So that's an interesting way of smuggling people into the country, and you can see why you would have to go on a crash diet to fit into that small compartment between the engine block and where the windscreen wipers are. And the other thing that was quite satisfying was that the whole thing snowballed. The investigation, basically, all of a sudden they found out there was not just one crime gang operating that brought people illegally into the country and then forced them to work for them, to work off the debt they incurred for having been moved or having been smuggled, because who lives in Vietnam and can afford £30,000 sterling to be brought to the UK? So they had to work off the £30,000. And they were worked off being cannabis farmers. This crime gang basically rented houses all over South Wales, stripped them completely bare, and converted them into cannabis farms. And the poor individuals that they smuggled into the country were forced to farm, i.e., to look after the plants and what have you. What this crime gang didn't know, however, and the police at the time neither, there was a second crime gang in operation. They had a completely different business model. They just watched what the first gang was doing, and every time they figured, oh, the time is right for harvest, they basically broke into the house, tied up the poor farmer, i.e. the poor chap who was basically the cannabis farmer, and then they basically raided the contents and made away with it. And this happened to this unfortunate victim that ended up dead in Quint Hospital, because the first gang felt he probably didn't put up enough of a fight to prevent the house being raided, or he might actually be in cahoots with the second crime gang. So they interrogated him, and they interrogated him a bit heavy-handedly, and not just using fists and baseball bats. Eventually, they interrogated him with knives, and unfortunately, he didn't survive that interrogation. But in the following investigation, unraveling all this, Trent Police and the Serious Organized Crime Agency, as it then was at the time, discovered there were a total of 158 cannabis farms in operation in the Gwent area. One actually made an estimate of more than £10,000 a month. And of course, from an evidence point of view, although the data we provided were not necessary for that, ultimately 3 Vietnamese members of this one gang were eventually charged, convicted, and jailed for the manslaughter of this unfortunate man. this is one of the farms that was raided then by police. So you can sort of guess basically how much money might have been tied up there. So basically, I'm just about only overrunning by 5 minutes, which is amazing if for people who know me. Multi-isotope signatures are a very powerful intelligence tool. They can provide decision-enabling information or decision-enabling advice, intelligence that help focus investigation, maximize resources, can cooperate or and strengthen existing intelligence or provide completely new directions. In the few cases or in 2 cases I was involved in, they even sped up court proceedings because the defendants, once presented with the evidence by the prosecutor, had changed their pleas. When it comes to unknown and unidentified persons, victims of serious crime, we cannot identify them, but we can provide, depending on the material available, enough information to kind of paint a picture. It's basically like a facial reconstruction, only you don't reconstruct the face. You basically you flesh out the person by providing information. Oh, they lived a healthy life, and let's say by saying that yes, they were an omnivore, but they didn't eat too much meat, which is supposedly not healthy, or they were a vegetarian, or they might have been a vegan, and on top of that, in that time frame, they moved from A to B. And all this basically builds up a picture that, of course, helps the police making inquiries in relevant location. But if they go for a public appeal, if a narrative like that is displayed, somebody might say, oh gosh, well, the face could be, but that story, that could be so-and-so. You see, it also basically helps jogging the memory of the public when public appeals are launched, because the more information there is, the more you can flesh out the life circumstance, the life history of a person, the better the chances that eventually that needle will be found, not by us, and then, of course, once you have that, you have, as a police, then, of course, the means by comparative DNA, for instance, to confirm that. And that happened. There's a case I was working on recently, mind you, recently it's now a couple of years back, where exactly that happened. Female body found in a remote location. Eventually, based on stable isotopes, we figured out how long she was in the UK, and when she entered the UK, where she originally came from, and lo and behold, inquiries at one of the potential points of origin, the parents came forward and said, this could be our daughter. DNA testing done, and lo and behold, it was their daughter. And the parents made exactly the point I was trying to make earlier, said, it's very sad what happened. We really mourn her and miss her, but at least we know what happened to her. So, lastly, acknowledgement. I skim over that. I'm quite happy to name. I mean, you can see the number of police forces who eventually put their trust in us. There were a lot of very, very dedicated PhD students involved. Nicola Farmer, Isla Fraser, Anastasia Holubinko, Claire Locke, Graham Reed, Lisa Reedy, Hilary Buchanan. She did a lot of the drug synthesis. Oliver Sutcliffe, he did also drug synthesis, but on the cathinones. Beneath Nick Deed, who supervised, who was the primary supervisor of these two various organizations who funded this. Lots of volunteers. Those are the volunteers who gave us hair and nail samples to help us build up a human tissue database. And last but not least, Dr. Helen Kemp, my lab manager, research officer, and as it so happens, also my wife. So, and in case anybody has the idea to ask questions, I like to remind you of this. I still don't have all the answers. I'm just, after 20 odd years, begin to ask the right questions. And in case there are even more questions, and because it was already mentioned before, I don't feel so bad mentioning it again. Everything you ever wanted to know about stable isotope forensics, but were afraid to ask, you find the answers in this book. And I know this is a shameless bit of self-promotion, but I couldn't resist because this, let's say, misquote of a movie title by Woody Allen, it was just too good to miss. And this is me over and out. And I thank you for your attention and for bearing with me, despite the fact that I overindulged you now for almost 10 minutes. My apologies, but my thanks. You're still?
Yes, we are here.
You're still here. I thought, gosh, it was awfully quiet. What happened? Everybody left.
No, we are listening very attentive your lecture, your brilliant lecture. Thank you so much. We have some questions here. I think you can read them. Most of them are in English. Can you read the Q&A?
Right, let me have a look and see if that works.
Sir, I can do it for you, but there are some very long questions. I think it's better for you to read
the first question was, I see here, is by Andre Sula, who wondered if I have ever gone through a situation when isotopic evidence was not confirmed by overwhelming. So, yes, we had several cases where which are still open inquiries because nothing has basically nobody has come, and not only in the UK but also elsewhere. There was one case in Canada where we really thought the public appeal should help solve the case, and because not only were stable isotopes and were done, there was facial reconstruction, there was even carbon-14 bomb curve analysis to get a handle on, because the remains were basically such that you could not say that the pathologist could not determine a time of death because they were so advanced, decayed. There was lots of information. We could show how the person had moved from A to B and where they actually stopped on the way. And yet this case is still open. So yes, this happens. And we also had cases where the isotopic evidence didn't show anything startling, because you see, the thing really works exceedingly well if you see differences, if there are changes happening. If somebody, just maybe a bad example, if somebody always lives in the same location and only eats beans on toast, yeah, or whatever, basically has a very monotonous diet, then yes, the isotope signatures will show that, but it will give you virtually nothing to go on. Yeah, there is nothing happened. So how? I mean, maybe sometimes even this information will jog someone's memory. But yes, that it does happen. And it particularly happens, or happened to me, or happened to us when we were dealing with murder inquiries. Sometimes, so basically, so far we had, I think, 3 cases where ultimately the victim was positively identified, and in one, though actually we had 4 cases, and in 2 cases of those 4 cases, convictions were made, i.e. the perpetrators, the killers, were brought to justice and were sent to jail. But there were at least 15, if not more, cases where this has not happened yet. And I've just yesterday received an email from a forensics department manager from a police force in the UK saying, oh, this case you worked on in 2009, we're having a case review. Has anything happened in the meantime by way of technological advances that would bring even more information to the table or not. And I had to say, no, I'm sorry, I've gone through the case report, looked at what we looked at the original data, and there is not much more we can tell, or there is actually nothing more we can tell. So yes, that happens. So the next question is how accurate, comparable is on good reference and normalization method. We also know follow. Haha, yeah. I mean, if you the second question deals with reference materials, accuracy, traceability, 2 or 3 point normalization, and the paucity of reference materials. I can only advise you very strongly. This is Maria Fasciotti. Not to assume that that the IAEA or UPAC are the only source of reference materials. Both organizations are, by their size, and this is not a criticism, this is just the nature of the beast, notoriously slow. I'll give you an example. There was a UPAC meeting in 2005, which in essence forms the basis of all the recommendations and guidelines we're working towards at the moment. These guidelines and recommendations that came out of that meeting in 2005, it took 6 years for them to be published in 2011. So this gives you an idea. So there are a whole raft of reference materials available. And the best source to look for them, to look for something that will fit your work or will at least be a chemical match. The reference materials do not have to be a one-to-one matrix match. That only applies to things like hydrogen analysis, for instance, of materials that are prone to hydrogen exchange because they contain OH groups or NH groups. But anything else, so for instance, if you're looking just at carbon and nitrogen analysis of a protein, then you can use USJS40 and USJS41A. Both are glutamates because an amino acid is a very good proxy for a protein. And those two reference materials have very disparate carbon and 15N values. So the USGS, the US Geological Survey, their stable isotope lab in Reston, which is run by Tyler Copeland. Go onto the website or search for that, or if you can't find it, don't worry. Ask Gabriela for my email me, and I email you this information, and also email you a publication that was headed or chaired or under the general leadership of Arndt Schimmelmann, where a whole raft of new reference materials that I wouldn't say certified, but definitely characterized, that provide not 3-point normalization, they provide 2-point normalization with a 3rd point halfway as a quality control. You know, it's similar to the principle of V-SMOP on SLAP, where V-SMOP and SLAP are the endpoints, and GISP is the half point in between that you use to quality control the quality of your normalization by treating the half point as an unknown. So so there are actually quite a lot of reference materials, and some of them that I just mentioned that are available through the Reston lab of the USGS are in the meantime listed on not on the UPAC webpage. You have to go to the webpage of the isotope section of UPAC, and that is CIAAW, the Commission of Isotope Abundances and Atomic Weights. They basically list, they have a list, but they don't sell. They just have they just basically list, and that list is continuously expanded. Yeah, lead isotope can definitely help. I know actually people in the US who looked at lead isotope in, was it bone or teeth, one of the two, to basically add another layer that will help. Because I mean, if you remember this map I showed you about precipitation, the US in particular, the US of A, they are almost a representation of the entire globe. Virtually every isotopic composition in precipitation you will find across the globe at disparate locations. You will also find in the US, which has some very funny implications. And because of that, strontium is already being used and has been used already in cases where unidentified bodies, let's say, were found in Texas. Presumably people who crossed the border from Mexico. And indeed, there were border crossers, but they didn't come from Mexico, but they came closer. I'm not sure which country, but closer to the isthmus, i.e., closer to Panama than actually Mexico. So trace elements are already being used, and work on that is already being done. Can't now remember the name of the lady who I think she has already published at least one paper, but that was sort of pilot data because they had a limited, and they used US Army personnel because the nice thing about these people is you know exactly where they are and where they were. So yeah, short answer, yes, lead definitely. And there are others. There is work by researchers in the Netherlands who have looked at neodymium, and I don't know whether they also looked at yttrium, one of the two. So there is a whole world of trace element isotopes still to be explored and pressed into service. Right. What else? Hang on. That was Claudia Regina Passarelli, and there is another question. Blah, blah, blah. No, I personally have not. This is from George Marcello Freitas. I personally have not applied likelihood ratios. I'm too daft. I'm too old. You know the saying, an old dog doesn't learn new tricks. This is what my younger colleague, Joran Hugewerf, this is not the only reason why I collaborate with him. He's a very nice chap, very conscientious, very good at what he does. But he got into R very early on. And whenever I have a question about likelihood ratios, I ask him. But I clearly see, I clearly see a future for that in this type of work. But I myself haven't reused it, and the only example I know of where LRs were presented to help basically with coming to a conclusion where a person had come from or a victim of crime was the example I showed you. But I'm sure Jurian has done other work, but I haven't seen it yet. So it presented in court. I don't think it ever has been. Yeah, question by Christina Barbieri. She wanted to know whether the error bars were standard deviation or standard errors. That's a good question. It depends basically where if I mean, we always analyze samples at least in replicates of 4. And I think it's debatable whether that is enough as a population size to call the error bars standard deviations. So I would, but what we do is actually the error bars are not okay. I can answer that by telling you what we do. We look at the error of the measurement, but we also of the actual measurement of the sample, but we also look at the error we see with the standards, which is basically why we use quality controls to check on the normalization or the isotopic scale calibration from the reference materials, and we propagate these errors. Yeah, so the errors are always a composite of what's they're propagated. They're basically the overall. They represent the overall uncertainty. So error of the sample analysis, let's say, plus error of the standards, because these two errors are never identical, even if the materials are chemically matched, because with the samples you always have, because you are in the hand of your samples, you always have this uncertainty of sample homogeneity. So if the sample is not fully homogeneous, you will see quite differences from one analysis to the next, even if taken from the same sample well, whereas your reference materials, your standards, are presumed to be homogeneous. So their error of measurement is always better. So in order to basically capture both, we basically do error propagation and report an overall error. Okay. Yeah, and this is the last question I see here.
Yes, is this? I'd like to inform you, Mr. Professor Meier-Augenstein, that we have over 100 participants here, which is a record attendance at our workshop.
Yeah, but that has nothing to do with me.
Of course, yes.
I'd like to sing so, but I don't. But I can't
know
imagine.
Everybody, so I can warrant you that. And I have a personal question.
Yeah.
It's about the acceptance of isotopic evidence in courts in the UK. If there are any specific criteria for acceptance, or what are the main questions or concerns in expert testimony or trials?
No, but this is what I've tried to convey in my talk. On the few occasions when we were basically when we were asked to give evidence, it never came to it, because days, or even in one case, one day before the trial, the defendant changed their plea. So far, this has not been tested in court. And I'm not aware whether it's been tested in court in the United States. I know that and Gabriela, of course, knows him better than I do, even though I've met him on several occasions. Jim Ehleringer at the University of Utah actually wrote, together with a colleague from the law faculty, they wrote actually a paper on that. And that's the only, that is it, which I referenced in my book, because that's the only reference I found where somebody had actually tried to think through what this means, what it would mean for these data to be presented and accepted. My personal view is there should not be a reason not to accept them, because in the meantime, there is a wealth of information. If you look at the number of publications that are out there, and you can't really see this is a fringe science. And this ties in with the question of one of the members of the audience. If the data are properly scale normalized, i.e., if the data are reported on the international accepted reference scales, if they follow the UPEC guidelines as put down in this paper that ultimately Ty Copeland wrote and was published in the Rapid Communications in Mass Spectrometry, and which is in a rich form available on the CIAAW website. So if the data are properly and of course, what helps which we had in my lab, we were, I wouldn't say accredited, but we had certification by the Forensic Isotope Ratio Mass Spectrometry Network, and that process was modeled on the ISO 17025 procedure. So we had for everything, we had an SOP, and we had records of everything. So provided records are meticulously kept, you have SOPs that clearly stipulate when data are accepted, when data are rejected, or when an analytical run is aborted because your quality controls don't meet your acceptance criteria. There should not be a problem, because ultimately what this technique does is not too different from what quantitative GCMS and LCMS does. And GCMS data and LCMS data are accepted, and the same, and because ultimately, even if the data are reported in this funny fashion on a reference scale, these are quantitative. Ultimately, they are quantitative data. You have a quantitative measure of how much carbon-13 there is compared to the scale reference, and so which is why we have to scale normalize or isotopically scale calibrate our data in the same way. Quantitative mass spectrometry has to provide calibration, on the day calibration, not on Monday and then we run samples until Friday and assume everything will be all right. No, contemporaneously calibrated, quality controlled, quality assured data. That's the beginning and the end of it. And then there should be no issue with having those accepted. And the other criterion for data to be accepted in court is there a knowledge base or is this fringe? And there is a knowledge base. We now have 20 years of knowledge base, more or less. in the peer-reviewed literature, and not just in whatever the journal of unreproducible results. We have basically everything into the top journals. Proceedings, National Academy of Science, Nature, Science. I've just reviewed a manuscript that goes into science reports in Nature. So this is no longer a fringe thing that basically hides away in some obscure journal nobody reads. There is so that are this other criteria of acceptance, accepted by the scientific community as a method, and the results accepted. All these boxes are ticked. We just need, and this is really the first case that goes to court, to actually have in essence the final proof, if you like. But going back to the beginning, no, in the UK so far, it has not been presented in court. Neither has it in Ireland, where one of the murder cases, where eventually the victim was identified with the aid of isotopes through a DNA cross-match, and where the killers were sent to prison. But the stable isotope data were never required. Yeah, so that test, to my knowledge, has not been done. And the area where stable isotopes have been presented in a kind of court, and I would be really sorely tempted to call this a kangaroo court, are the proceedings of the World Anti-Doping Agency. But I mean, if you have a proceeding where you have 3 people deciding on the outcome, and 2 are hand-selected by WADA, and only 1 is independent, what are the chances that an athlete will actually be found innocent or not guilty? Yeah. So stable isotope data have been used in court, in so-called not really court proceedings, but in hearings that have to do with anti-doping violations. And there the technique, especially to determine the use of synthetic steroids, is using carbon-13 as a proof of steroid abuse is accepted by WADA. Whether that will eventually be accepted in a real court of law, I don't know. We have to wait, because Germany a couple of years ago actually changed the law, and now anti-doping violations have to go to court, to a criminal court. So in Germany, an anti-doping violation is a criminal offense. So we have to see until the first German athlete will be found, or at least will be declared a suspect. I don't. Does that is that? I don't know whether it's a satisfactory answer, but is that an answer?
Yes, perfect.
Good.
We have many people here in the chat congratulating you on your excellent class. So I will call Professor Gabriela to thank you in the behalf of the National Forensic Isotopes Network.
Thank you, Marinki. Thank you, Professor. That was a wonderful presentation. And I would like to extend my sincere thanks to everybody in the audience. It's more than 100 people here. So we really enjoy your talk, inspiring talk, and also for sharing all your knowledge, your experience in isotope, and answer these questions. It's almost another talk. We could ask a lot of other questions here. We can stay the whole afternoon, but maybe another case, another time, because I know you have a lot of work to do.
I mean, let's say on a positive note, I'm not claiming I've attracted all the 100, but on the other hand, I haven't chased anybody away. Nobody has left. So we take that we take that as a good sign.
And I'm looking the photo of your book here, and I would like to say that in public, that your book inspired us to write our Portuguese book in Brazil. We put here the Brazilian case, more the everything that is more specific to Brazil, but your book inspired us. And also your first message that you sent back to me in 2019 remember that you could not come to, to say in our workshop because of personal, issues there, but your message inspired us to keep doing this in Brazil. So I would like to say this in public.
It's very, very kind of you. Thanks very much.
But that's true. So that's why I'm telling to you right here, right now. Okay.
Right.
So
Thanks.
thank you so much for being with us in the last 1 hour.
It was a pleasure. And thanks again for having me. That's very much appreciated.
Okay. So thank you.
Thank you, Professor.
Right. So I'll stop sharing and then I'll say goodbye because it's good heavens. It's 20 past 8 here. So yeah, and it's dark. So
good night, Professor.
So no, I'm not. I probably won't be able to sleep for another hour. So I might actually read something. But all the same, I've been up since 7 o'clock, so I can tell, and I'm not getting any younger. So I need my beauty sleep. Not that it will help, but I'll try. So I'll wish you and all the best for the rest of your workshop. And again, thank you very much for inviting me along. I was glad to be there, and have a good time and lots of success for your work in forensic isotopes.